In this lesson, we're going to learn how to find the area of a segment in circles. So let's get started. A segment of a circle is a part of a circle that is bound by an arc and a segment joining the arc's endpoints. And so we have two examples here, one of a minor segment and a major segment. As you can see, the minor arc here creates a minor segment, and a major arc creates a major segment. And of course, the line here, the segment with the endpoints. So this segment of the circle is bound by the segment of these two endpoints as well as the arc. So let's look at the steps to find the area of a segment. The first thing you want to do is label the radii and find the area of the sector. So we have a sector here. And so the formula for area of a sector is n divided by 360 times pi r squared. N is the arc degree, or the degree of the arc. So if this angle was 60 here, then of course the arc would be 60 as well. And so if you notice here, this is pi r squared, so really you're just dividing the arc by 360 and multiplying it times the area of the circle. So this should look familiar to you right here. Next, you want to find the area of the triangle formed by the radii and the chord. So remember the chord, this is our chord right here, the line that goes from one edge of the circle to another edge. That is a chord. And our formula for area of a triangle is area equals 1/2 base times height. You may have to use some trig to find the base or height, but that is the basic formula for area of a triangle. And then you would subtract the two numbers. So you would subtract the area of the triangle from the area of the sector. Put a minus sign there. And so here we're left with the area of the sector. So step one, the area of the segment. So step one, find the area of the sector. Step two, find the area of the triangle, and then subtract the two numbers. Let's take a look at problem 1 here. It says find the area of the segment. So of course, first we want to find the area of the sector, and we use this formula here. And if you're not familiar with how to find the area of a sector, please see my video finding the area of a sector in circles. N, of course, is the arc measure. All right, so it's going to be 90 because this is a right angle. So this is 90 degrees, so our arc is 90. So that would be 90 divided by 360 times pi. My radius here is 4. So 4 squared, pi r squared. Multiplying all that through, well, let me simplify it a little first. 90 divided by 360 will give me 0.25. 4 squared is 16, so times 16 pi. And I'm just going to put all of that in my calculator. 0.25 times 16 times 3.14. That gives me approximately 12.56 meters squared. So that's the area of the entire sector. Then I want to find the area of the triangle. So 1/2 base times height. And notice here we have a right angle. Since this is a right angle, that tells me that that 4 is the altitude or the height. So that my height would be 4, and then the base would be 4 as well, because remember the radius is the same. So I'm plugging that in. The area equals 1/2. Base is 4. Height is also 4 because we have that right angle there. And that will give me 8 meters squared. And then I just subtracted 2. So area of the sector is 12.56. Area of the triangle is 8. And I'm left with 4.56 meters squared. And I have found the area of this segment. So problem 2 here, of course we want to find the area of the segment. And of course we want to find the area of the sector first. So in this case, n is 60 because we have a 60-degree angle here, so the arc measure is also 60. Times pi r squared. So 18 squared, that is my radius. And I'm going to just plug this straight into my calculator to save some space here. 60 divided by 360 is equal to 1.6 repeating. I'm going to multiply that by 3.14. So times 3.14, which is pi. And then times 18 squared equals. So I just plugged in everything at once, and I get 169.56 inches squared. All right. So now we want to find the area of the triangle. So this one is a little different because we don't have a right angle here. So, and so that doesn't give us the altitude. So our altitude will actually, I'm going to draw a dotted line here. So we're going to have to find this altitude. So let's look at it. So CA is congruent to CB. And we know that because they're both radii, right? So that would make their opposite angles congruent. They're both 60 because according to the triangle angle sum theorem, there's 180 degrees in a triangle, all right? So if this angle here is 60, if we subtract 60 from 180, we get 120, all right? And so we're left with 120 degrees in that triangle. If we divide by 2, we get 60 because, so these angles would be 60 because their opposite angles are congruent because the radii is congruent. So now we notice that we have an equilateral triangle. It's equiangular because we have 360-degree angles, so all of their sides would be congruent or equal. So this side here would also be 18. All right. So now I can kind of break this up into two triangles right here. And the altitude would create a right angle here. So sorry about that. So we will have to have that right angle there. And notice we have a triangle and it is a right triangle. What do we use whenever we want to find the side length of a right triangle and we're given two lengths? We use a Pythagorean theorem, remember? So that is a squared plus b squared equals c squared. So the whole side here is 18, so each piece would be 19. We cut that side in, not 19, 9. So we cut that side in half. And so my height here would be one of my legs. Lost for words. So the height here is one of my legs, and so the hypotenuse is 18. All right, so plugging it in. So a squared, so one of my legs is 9, right? So I cut that side in half. So 9 squared plus b squared, which is really, and I should have used a different variable because I'm not looking for the base, I'm looking for the height. So I should have actually used h, but Pythagorean theorem, our legs are a and b. So that's 18 squared. So 81 plus b squared is equal to 324. Subtracting. That gives me 243. Subtract the 81. Then I just take the square root. And I get 15.59. I'm just going to round it to the nearest hundredth here. So I haven't even found the area of the triangle yet. I did all that to find the height. So plugging that in. So area equals 1/2. The base is 18. All right. So I can see my base here because all the sides are the same. Base is 18 and the height is the 15.59. So multiplying that through, I get 140.31 inches squared. Now I can subtract. Different color here. 169.56 minus 140.31, and that gives me 29.25 or 29.3 if I round to the nearest tenth, and that would be inches squared. So the area of that segment is 29.3 inches squared. So the last problem we want to try here is actually a square, but we can use our knowledge of finding the area of sectors and segments to solve this problem. And we want to find the area of the shaded region and leave our answer in terms of pi. That just means that we're not going to multiply pi through. All right. So our first step is we want to find the area of the square. So we know that the square has all congruent sides. So this is our congruence mark. So if this length is 14, this length would also be 14. So the length of that side would be 28, as well as all of the sides. So you know the area of a square is base times height, or base squared. So that would be 28 times 28. That leaves me with 786 inches squared. So that is the area of the square. And next we want to find the area of the sectors, which are the white regions. And what do we notice about the sectors in this diagram? We have 4 of them, right? And they all have congruent sides. So we could actually find the area of a whole circle since we have 4 quarter circles here. And remember the formula for area of a circle is area is equal to pi r squared. And so what is r? R would be 14. How did I get 14? Because if we have this edge here, and this would go from the edge to another side. Let me change the color. The edge here. So that would be like the center of the circle, right? So that length is 14. So our radii would be 14. So just plugging that in, and again we're leaving this in terms of pi. So it'll be pi times 14 squared. So 14 squared is 196. So I'm leaving that there. And our last piece is we just want to subtract the area of the circle from the area of the square. And we're leaving our answer in terms of pi. They are not like terms, so I cannot combine them. So my answer is simply 786 minus 196 pi. And again, I cannot combine them because they are not like terms. The 196 has a pi and the 786 does not. And so that is our final answer. Of course, if you wanted to not write it in terms of pi, you would just multiply the pi through and simplify it that way. All right. So we have solved this problem finding the area of the shaded region. All right, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are tangent lines part 1 and 2 and arc lengths in a circle. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.